Hello everyone, welcome to the Go Code Snippets channel. This channel is all about the Go programming language, and if you're new to the channel, please make sure you subscribe. And after watching this video, if you like the video, hit the like button and also hit the notification bell so when I release new videos, you'll be the first to be notified. So today we'll be talking about files and folders in Go. So we'll be talking about creating files, writing to files, reading from files, deleting files, and also creating directories and folders. So in this part of my main.go file, I just made a comment on the things we'll be doing. So we'll be following them just like they are being highlighted here. So the first thing now is to create files. So to create files, we can basically use, although there are other ways, but these are the most common ways that I have seen most times whenever I see the code or that people have written, or if I also want to work with files. Most times to create files, what you usually see is OS create and Iot Template. Most times OS create. So the first one is OS create. So to use OS create to create a file, just call the function create from package OS. So I have to import package OS. So if you check the documentation for OS create, so OS create takes in the name of a name which is string. So this name is the name you want to give the file, and it does a pointer to a file and an error. So we'll just give it, let's say we want to give it a file name, file.txt. That's the name. So it returns two things, a pointer to a file, so we call it f, and an error. So this OS create, the way it works is if you want to create the file into a particular folder, not this current directory, because this like this will be created into this current directory, which my main.go file is. So let's assume that there's a subdirectory here and I want to create in a subdirectory. So it just be the path to the directory, then the file name. So that is how it works. But since we're creating it in this current directory, I'll just leave it as file.txt. So we'll check for the error. So I can just print create a file, enter the, then I'll return. So else, the next thing I want to do now is very important. I have to close the file when I'm done with it. So that is how you create a file using OS create. So let us run the code and see if our file will be created in this current directory. So yeah, I'm having just my go.mod and my main.go. So let me run the file now. I think I'm having an error because I didn't import log, I think. So if everything goes fine, we should just see our file created. So I'll run go on main.go. So yeah, it has been created. So now I'm having file.txt, but my file.txt there's nothing in it. So something will actually put something until we get to writing to files. But for now, I just creating files. So the next function to create a file is func temp file from package iotil. So iotil is actually in the path io/iotil from the standard library also. So I have to import that. So we're using function temp file from iotil. So I'll just call iotil temp file. So before that, let us see the documentation. So if I do code doc iotil temp file. So Iot temp file takes in two parameters. The first one is the directory we want to create the file in, and the second one is a pattern of type string. So they are both of type string, and it returns a pointer to a file. So you can see it is pointer to a file from package OS2 and an error. So this one returns a file and an error. So two parameters. First one is directory. So let's create it in our current directory dot. Then the second one is a pattern. So the way this pattern works is if you specify a name, so this pattern is just the name that the file will be given. So if you specify a name, let's say I just specify maybe file2.txt, a random string will be generated and added to the back of this file2.txt, this file2, before it is being created. So let us just run this and see what we get first. I didn't use error sign. Oh, sorry, the code again. So we'll check for the error first. Sorry, my bad. We didn't finish the code. So print then we'll return else. So we have to also close it again. So I'm more using package OS. I'll just comment this out. We'll roll the code and see what we get. I think it's capital F. That's error I'm getting. Or is it small f? It's capital F. I use a temp file. It's capital F, not small f. So now that we ran this, we saw that a particular random string was generated and added to the back of this .txt. So to control where this particular random string will be, you can use the asterisk symbol. So here, instead of having file2.txt, I'm going to put file2 or file star. So this star here, this asterisk symbol means that this random string, I want it after this file that I created. So it's going to be file 2 to whatever the random string is, then .txt, that will be the file name, instead of the random string being added after the .txt, because that is the way Iot Template file works. A random string will be generated and added to the back, to the end of the pattern that is specified here. So let us run it and see what we get this time around. So now it has been created, but instead of our random string to be at the end after .txt, it's actually put here after the file, because that's what we specified the random string to be before it. So I will manually delete this one. So that's how Iot Template file works. So that is for creating files. So next, now we are writing to files. So to write to our file, the first function we'll be using is function iot write file from also package iot. So if you check the documentation for iot write file, iot write. So iot write file just takes in the name of the file we want to write to, then the data, which is a slice of bytes, and also a file mode. So we're having iot write file. So this one takes in three parameters. The first is the name of the file we want to write to. So I'll be writing to file.txt. Then the second one is the data I want to write. So let's say I want to write a slice of byte, which is just simply hello world. Maybe it is. Then the third one is a file mode. So the file mode I'll be using is 0666. So this 06, whatever this file mode there is, actually there's an article on Wikipedia about ch mode. So you should go and read it out. It's a very great article. It helps you understand what this file mode means. So this 0666 means I want to give a read or write access to the creator, which is me. Then the read or write access to the group. Let's say I'm working in the group. I want other people to have access to this file, read and write access to this file. Then this one is for other people outside the group, which also read and write access. So you just go to Wikipedia and check an article on ch mode. So it's going to explain how everything works. So that's how file mode works. So from there, this one returns an error. So I'll just simply say if error. If error equals to this. error not equals to nil. So I'll just say log print name. So I'm calling it, I'm also handling the error on the same line. Error creating file. I want to, let me return. I can just simply do an else statement instead of returning else. Fully written to file.txt. So one other thing you need to take note about Iot write file is important. Or two things to notice, two things to take note of is that Iot write file, the way it works is here I'm actually writing to file.txt and I already have file.txt here. So let's assume that I didn't have file.txt. File.txt will actually be created. Immediately I call Iot write file with this permission here. But since I have it already, just simply write to it. But if I don't have it, it's going to create it and write to it with this permission. That's how I will write file works. So let's assume that I don't have a file.txt, which I have. It will be created and written to. But since I have it, just write to it. So that's how I will write file works. And the second thing I need you to take note is that right here, it is written that as of Go 1.16, this function simply calls OS write file. That means there's also OS write file. So if I do, there's also function write file in package OS also. So it is also, it's basically the same thing they do, the same parameters and the same return value. So it's still the same thing. So I think they just moved the function write file to package OS after Go 1.16. So if you're using a version before 1.16, you have to use IoT write file. But any version after 1.16, you can use IoT write file or OS write file. Like me now, if I do Go version, my version is 1.16, which is the current version I'm using. So I can use OS write file. But if I was using 1.15, I have to 1.15, I have to use IoT write file, not OS write file, because it was after 1.16 that write file, the function write file was moved to package OS. So IoT write file just calls OS write file. That is what was specified in this part for the documentation for this part for the documentation for IoT write file. So that's for IoT write file. So the next way to simply write is using the methods write and methods write string. So if you take note that all the files we've been creating, they are of type pointer to OS file. So if we check the documentation for type pointer to OS file, so if you do go doc OS file, so we have these two methods here, methods write and methods write string. So we have method write string right here, which takes in a string and returns an int and an error. Then we also have method write that takes in a byte and returns a slice of byte and returns an int and an error. So to use this tool, we just simply, so we'll just do something. I want to write to file.txt. So before if I'm written to, so I didn't run our code before. Oh my bad, I didn't run the code. I just cancelled this. Let us run it because we should have written to it. Let us run it. We didn't run it. That was a mistake on my part. I'm very sorry for that. So let us run it because we should be having hello world inside our file.txt. So if you run it, it's saying I don't have fonts. I have fonts. So we're having successfully written to file.txt. So if I check my file.txt now, I'm having hello world in it. So that is that for that. So the next one now is now writing. So as I was saying before, we have two methods write and methods write string. So to use this tool, I have to first open the file I want to write to. So I'll do OS open. So OS open actually opens a file for reading and writing. So I'll specify the name of the file because OS open takes in code.os. So OS open just takes in the name of the file you want to open, which is a string. Then it returns a pointer to a file and an error. So it just returns the file and the error for us. So I want to open, or let me write into file this.txt. So I'll just copy it. 521579431.txt. So that is the file I want to write to. So let me just check if the number is correct. I didn't make a mistake. So this one returns a file and an error. So check for the error. So just print out print. Right. So error opening. And I'll return. Else I want to defer the closing of the file because I have to close it when I'm done with it. So won't be holding on to memory by no using. So after that, it's telling me that I didn't import OS. So I have to uncomment this. So now that I've opened the file, now next thing I want to do is to write to it. So to write it, I'll simply call the write method first. So what the write method takes in is a slice of bytes. So slice of bytes. So I want to write hello goofers. So that's it. Then so let us run this first. So this one returns two values. So if we check in our signature for the write function, it says returns n, int, and error. So this one returns two values. So we don't need the n. So just check for the error instead. You can put an if statement in front of it also. So error equals. So we just want to print out writing. So then else we just simply want to print out successfully. So print out successfully written. So 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 let us run it. That's what we get. I didn't use Iot. So let's comment it out. So it says access denied. Writing to access denied. The reason why the access was denied is maybe when we were creating a file, we didn't give it writing access. That is the most likely reason. So that should be the reason. But no, usually we shouldn't have an error. But because we didn't give access to writing, I think I need to go and do some permission stuff on the file. But that is how it works. So the next one is also write string. Write string is the same thing. So we just simply change one to write string instead of write. Then instead of slice of bytes, we just simply give it a string instead of a slice of bytes. So if you run it, you will still be getting the same error that access is denied. I need to go and do some change some permission stuff on my machine. That is the reason why it's not writing, but usually you should write to it. So that is how to write to files. So if f.write and f.write string is not writing, is not working, we used IO to write file. So let's see IO to write file. Let's try IO to write file on this and see if it's going to write. So just do IO to write file and see if it's going to write. So if equals IOU to write file. So IO to write file like before it takes in the name of the file, what we want to write to it. So we want to write, which is a slice of bytes. So we want to write slice of bytes. Hello, go fast. Then 0777. So if error is not equals to name, so we'll check for the error. So we just want to send to. So let us run the code now and see if we still have access denied. Should be a comma. IoT write file is writing, but f dot write and f dot write string is not writing. Well, that will be a topic for another day. But for now, just know those are the three ways you can write. There are other ways, but those are basically the main three ways that you can use to write to files. So let's see my file. I'm having a logo first, so it has been written to. So the next one now is reading from files. So to read from files, the first function we'll be using is function read file from, also IoT read file. So if we check the documentation for IoT read file, go doc IOUT read file. So IOT read file just takes in the file name, the name of the file you want to read from, then returns a slice of bytes and an error. So this slice of bytes is the bytes written from the bytes read rather from the file, and it also returns an error. So it also says displays also that as of Go 1.16, it just simply calls OS read file. And there's also a function read file in package OS that IOT read file just calls. So if you're using a Go version after 1.16, you can use iOS read file as also OS read file. But if you're using one before, a version of Go before 1.16, you have no choice than to use IoT read file. So we'll call IoT read file. So this one takes in the file name that wants to read from. So let us read from this file first. So this one returns a slice of bytes and an error. So byte slice and error should be this. So we'll check for the handle the error. And we'll return. Else we'll just print f. So we'll say read percentage d bytes as percentage of this file. So we'll just give it len bs and also string Yes. So what we're just doing is we're just reading. So what this percentage D is just the length of the byte slice that we read, and this percentage S is actually what we read from our file. So let's just run the code. So we read 13 bytes. So we read 13 bytes as hello go fast. So because that's what is in file 52157943.txt hello go fast. How we read from it, and everything is 13 bytes from this file here. So if you are to count it, hello is 5, then go fast is 7, that's 12, then plus this space in between, that is 13. So that's 13 bytes that we read from it. So then the second way to read from files is using the method read. So method read is also from package os. So if you do go doc os read, let's see the documentation for os read. Os read takes in a byte slice and returns an int and an error. So this int here is just the length of the byte that was read from the file, and it was an error if there is a particular error. So we have to create a slice of bytes that we want to read into. So we can just say reader should be, so we are going to make slice of bytes, let's say 20 with the length of 20. So we want to first open the file, so we say, so let us open it. Os open, so let's open file.txt this time. So we want to read from file.txt this time. So undo the error. So we want to print out file.txt and return. So we define the closing of the file. Then the next thing I want to know, that we've actually opened this, is now to call the read method. So say f.read reader. So we're reading into our reader. So this one returns an int. So n f.read reader. So we'll undo the error. So if the error is not equal to, so error reading from file.txt, we'll check our error. Then if all is well, there's no error, so we'll just simply print out read percentage d as from file.txt. So what we're passing here is n, which is the length of the byte that was read, and also we'll be passing string reader because we're reading into our reader. So whatever information we read from f will be stored in reader, which was the slice of bytes we made here. So we'll just print out as a string and see what we read. So we'll just run the code. OS and Iot. So let's rerun the code. So we read 12 is meant to be percentage d bytes. So we read 12 bytes as hello world from file.txt. So this space, yeah, so we read 12 bytes as hello world from file.txt. So this n here is the amount of bytes read. So if you look 12 bytes, that is 5 for hello, 5 for world, that's 10. When with this exclamation mark 11 and the space, that is 12 bytes that we read from the file. So let's assume that we actually make the length of our reader, let's say it is 5. Let's see what we get if it is not up to, because in our file.txt we have a, so the bytes in our file.txt is actually 12 bytes. So let's assume that the space we are actually telling the machine to give us is a space of just 5 bytes. So let's see what happens. So yeah, we weren't able to, we were just able to read hello. We couldn't read everything. So but, and that's the problem with using read. So if you actually know the amount of bytes you want to read from the file, you can always use read. So if you have a file that has a very long length, that maybe the words in this file is about 1,000 bytes, and you know it's 1,000 bytes and you want to read everything, you can just put in 1,000. But if it's a very long text and you don't know the size, and you want to read a particular amount, let's say you want to read 30 bytes, you can use read. But let's say you want to read everything and you don't want to have to start reading or have to start calculating the number of bytes in the file, you can just use read file instead of read. So that is just the thing. So the next thing now is deleting files. So to delete files, that one is straightforward. We just use the function remove from package OS. So this is it, OS remove. So if you check the documentation for OS remove, so OS remove just returns an error and takes in the name of the file we want to delete. So just simply say if error equals to OS remove. So OS remove just takes in the name of the file.txt. So we want to delete file.txt. So we'll handle the error. Print it out. Or else we just print out deleting file successful. So that is just that for deleting files. So run the code. So if you notice in this place we have our file.txt, when the code runs it will be deleted, so it won't be here anymore. So it has been deleted, we are not having it anymore. So that is just all for deleting files. So the next thing now is creating directories and folders. So we're working with files since we want to work with folders now. So to create a folder, we just be using the function makedive from package OS. So if you read documentation for makedive, go doc os makedive. So makedive just takes in the name of the directory we want to create and the file mode also, and returns an error. So we want to make a directory, let's say files, that's the name we want to give the directory, then the file mode, let's 0777. So this one returns an error. So I can just declare and undo on the same line. So error creating folder. See the error, we'll return afterwards. So else we just print out successfully created folder files or directory files. So let's run it and see what we get. So yeah, we're having just three files. We don't even have a directory at all. So when we create, it should be seeing a folder files. Yeah. So we're having a folder files, which is the new folder that we have. So we can move this file into it if we want. So I want to move this full file into it. I've moved this into it. So then the second one is OS make die all. So the reason why the difference between OS make die and OS make die all is you can actually create multiple directories, like multiple subdirectories, using OS make die all. So to do that, we just simply you change this one to OS make die all instead of OS make die. Having OS make die all. So I want to create path to files. So this will create a directory path from our current directory. It's going to create a subdirectory too and a subdirectory files also. So successfully creating directory path with subdirectory two with subdirectory directory files. So we're creating directory path. So let's run this. So here we are having paths, another path we're having directory two, another directory we're having directory files. So that's what OS make that all does. Then the third one is using Iot Template. So to use Iot Template, so first we check the documentation. Go doc IOUT template. So IoT template takes in the directory and the pattern. So this one is also similar to IoT temp file also. So the pattern works the same way also. If we don't give an asterisk in the pattern, you just create a random string and add it to the end of the name we give in the pattern. So what that means is that, so let's say we want to create the directory in our current directory. So we want to create it in this current directory, or let's create it in path to file instead. So from our current directory, we want to create a new subdirectory under directory files. So we want to create it under path to die. I want to create it in, or path to files rather. So we want a new subdirectory under files. So the second one is the pattern. So the pattern is just the name we want to give the directory. So let's give it my die. So I'll be putting an asterisk here. So I want to have an asterisk. So if I put my asterisk here, so this is where the random string will be created. So if I put it in here, if I put it here, it's going to be created here before putting my die. So that is how the template works. Then it returns the name and an error. So the name will be whatever the random string is generated with my die. So this one returns name. So we'll check for the error. It's a new subdirectory. Directory. So else we just print out the name of the file. So just print out successfully created a new directory with name percentage s. So with the name of the directory, so it should be printf, not println. So now I'm running the code. So let's see what happened. Okay, OS. So it has been created successfully today. So this is the name, part to file. So this is the new directory here, which is this last directory we had there. So if you notice that a random string was added in front of my die, because that's why I specified the random string to be. This asterisk sign represents the random string. So if I want it to be inside my before die, so I'm going to put in a random string here. So if there are two random strings, it actually works with the last random string. So if I put one here and I put another one here, so this random string will actually be here because this is the last asterisk sign. So it's last asterisk sign that determines where the random string will be. So that is all about creating files and creating folders in Go. So that will be the end of today's video. Once again, if you are new to the channel, make sure you subscribe and also hit the notification bell. And if you like this video, hit the thumbs up and also share.